Hello and welcome to part 7 of AWS Certified Solution Architect Associate exam crash course. Let's dive into architecture concepts. Now let's look into decoupled architecture. In the past, applications were tightly coupled, with changes in one part easily disrupting other services. Coupled architecture, on the other hand, allows different components to operate independently without being closely tied to each other. This means that changes to one component won't affect others, enabling faster and more efficient development. In the event-driven architecture, services are triggered by events that occur within the infrastructure. These events could be changes of state, like an EC2 instance transitioning from running to stopping. This architecture typically involves a producer, an event router, and consumers, with the event routing ensuring that the producer and consumers are decoupled from each other. As you go through this course, we will introduce to Amazon SQS, a commonly used AWS services in decoupled architecture. So stay tuned to learn more about these powerful architectural concepts. Let's dive and understand the capabilities of AWS Lambda and AWS Step Functions. AWS Lambda is a powerful resource for serverless compute, but it has limitations. For complex operations, the 15-minute execution time may not be enough. AWS Step Functions, it acts as a state machine service, allowing you to create interactive and complex systems with complete orchestration and ease of transparency. AWS Step Functions operate by reading in your workflow from an Amazon state language file, providing a visual representation of your state machine right in the console. There are 8 states that your state machine can be in at any time, include pass, task, choice, wait, succeed, fail, parallel, and map. With AWS Step Functions, you can overcome the limitations of AWS Lambda, creating powerful, fully serverless applications and workflows. Understanding decoupling in application development and messaging services. A decoupled application allows each component to perform its task independently, remaining completely autonomous and unaware of each other. A change in one component shouldn't require a change anywhere else, and a failure in one layer should not propagate to other layers. This is in contrast to tightly coupled applications, where a failure in one layer may negatively impact the following layer and impair the entire application's functioning. Introducing messaging mechanism. Decoupling is made possible by introducing a messaging mechanism, ideally a one-to-one message passing model. The Amazon Simple Queue Service (SQS) is suitable choice for this type of implementation, behaving like an email system for different application layers. It allows for asynchronous connectivity of systems and enables the increase or decrease of EC2 instances processing messages in parallel. Message flow in a queue. The general flow of a message in a queue involves an application producing a message and sending it to a queue, followed by a consumer picking up the message to process it. The message is locked and a visibility timeout is set, ensuring that each message is maintained until the consumer finishes processing it and issues a delete message call to the queue. Managing visibility timeout. The visibility timeout for a message in a queue by default is 30 seconds, with a minimum of 0 seconds and a maximum of 12 hours. If processing a message will take more than 30 seconds, the visibility timeout should be increased accordingly to meet the application's processing time. Let's look into the difference between short polling and long polling in Amazon SQS. Short polling is the default method for listening to messages in a queue. It sends a response even if no messages are available. These can lead to an overlimit error if there are too many in-flight messages. On the other hand, long pooling waits for a specified time to collect messages, reducing the risk of errors due to message value. If a message isn't processed successfully, it can become stuck in a cycle. To prevent this, you can use a dead letter queue to capture and examine problematic messages. So understanding the differences between short and long polling, as well as the importance of dead letter queues, is crucial for effective message management in Amazon SQS. If you are a developer looking to simplify the process of message ordering preservation and message deduplication logic, well, using FIFO SNS topics in combination with FIFO queues might just be the solution you have been searching for. As developers, we often need to design applications with components that ensure processing a message more than once does not create any errors or inconsistencies. This is known as idempotency. By using an SNS FIFO topic, you can configure a message group by including a message group ID when publishing to the topic. This allows all messages to be sent and delivered in the order of their arrival, while also avoiding duplicate message deliveries through content-based message deduplication. Using SNS FIFO topics and SQS FIFO queues together allows for the implementation of application components that are idempotent by design, simplifying the complex process of message ordering preservation and message deduplication logic. So if you're ready to reduce the effort required to process high throughput, consistently ordered transactions and simplify your messaging architecture, consider leveraging FIFO SNS topics and FIFO queues. Achieve idempotency at the messaging layer without having to modify your applications. If you're considering migrating your existing data center applications to the AWS cloud, if you're already using messaging APIs like Java Message Service, .NET Message Service, MQ Telemetry Transport, or WebSockets, Amazon MQ might be the solution you're looking for. Amazon MQ is an AWS managed message broker service for Apache ActiveMQ designed to enable seamless migration of messaging and applications without the need to rewrite your code. It's cost effective, automated, and highly available with features like message encryption, network isolation, and seamless integration with Amazon CloudWatch and AWS CloudTrail. So consider Amazon MQ when migrating existing applications that are already using a message broker and you want to keep your applications as they are written. If you are curious about real-time data processing and its impact on modern applications, let's dive into the world of Amazon Kinesis data streams and explore its powerful capabilities. Real-time processing is crucial for applications like the stock market and the Internet of Things devices. Imagine receiving an alert from your home surveillance systems while you're away. It's essential to get that alert immediately. This is where real-time functionality becomes indispensable. Amazon Kinesis data streams is designed for real-time data collection and processing. It contains a copy of received data for up to 365 days, allowing large data sets to be ingested and stored. With the ability to process large data sets in real time, it's a game changer for streaming applications. A stream consists of shards, each storing data records in sequence. Producers put data into the stream and consumers process it using the Kinesis client library. This library ensures decoupled, fault-tolerant, and load-balanced consumption of records from the stream. So in summary, Amazon Kinesis data streams offers automatic data encryption, low put-to-get latency, and the ability to handle gigabytes of data per second. It's a powerful tool for real-time data processing and replaying records to multiple consumer applications. And if you're looking for a seamless way to handle large data sets and deliver them to various destinations, let me introduce you to Amazon Kinesis Data Firehose, a fully managed service that can transform and load your data to destinations like Amazon S3, DynamoDB, and more. Amazon Kinesis Data Firehose takes care of all the infrastructure, storage, networking, and configuration required to ingest and store your data. It automatically scales and replicates data across 3 facilities in a region, ensuring reliability. With buffer sizes ranging from 1 megabyte to 128 megabytes of S3 and the ability to compress and encrypt data, it offers flexibility and security. Unlike Kinesis data streams, Kinesis Firehose does not use shards and is fully automated in terms of scalability. It can seamlessly integrate with various applications and systems, including the Kinesis agent, which is available for Linux systems and web servers. When using Kinesis Firehose, you pay for the amount of data going through it, while it operates fast. It's important to note that there may be latency of 60 seconds or more when storing data to destinations. Amazon Kinesis Data Firehose is a powerful fully managed solution for handling large data sets and delivering them to AWS storage services. With its seamless integration and automated scalability, it's a valuable tool for businesses looking to streamline their data delivery processing. Now let's see how to perform real-time analysis on Kinesis data streams. So let me introduce you to Kinesis Data Analytics. Kinesis Data Analytics allows you to use structured query language to query data in Kinesis data stream and or a Kinesis data firehose, and then store it to Amazon S3 and OpenSearch cluster or Amazon Redshift cluster. It's a fully managed service with built-in auto-scaling, which can create streams out of real-time queries as a result. For new projects, you can use the Kinesis Data Analytics Studio, which provides you ease of use with advanced analytics capabilities and lets you build streaming processing applications in minutes. With Kinesis Data Analytics, you can harness the power of real-time data analysis and effortlessly build streaming processing applications. Are you curious about stream processing, machine learning, and artificial intelligence within cloud computing? Let's dive into the world of modern stream processing tools and the increasing demand for specialists in this field. Stream processing is the act of reacting to data while it's in motion. Unlike batch processing, which analyzes data in fixed chunks, stream processing allows for real-time reactions to data as it's produced or received. The value of data changes over time, and stream processing addresses issues of latency, session boundaries, and inconsistent load. It's crucial for industries like e-commerce, finance, healthcare, and security that require immediate response to data. Real-time trading in commodities and global product launches are just a few examples of where stream processing plays a critical role. The ability to recognize important events and act on them immediately is essential for businesses in these sectors. So stream processing provides actionable insights within milliseconds to seconds of a recorded event, making it a vital component of modern cloud computing. So now, are you ready to dive into the world of Amazon Kinesis? Let's explore the powerful data streaming services offered by AWS. Amazon Kinesis was designed to simplify the complexity and cost of streaming data into the AWS cloud. It offers an easy way to collect, process, and analyze various types of data streams in real time or near real time. Access to Kinesis is controlled using AWS Identity and Access Management. Data is automatically protected using the AWS Key Management Service and TLS for data in transit. Amazon Kinesis is composed of 4 services: Kinesis Video Streams, Kinesis Data Streams, Kinesis Data Firehouse, and Kinesis Data Analytics. So Amazon Kinesis provides a comprehensive solution for streaming and analyzing data, offering a range of services to meet diverse data streaming needs. Now let's talk about the power of real-time data streaming with Amazon Kinesis. Streaming data has a wide range of use cases, from industrial automation to IoT analytics and log analytics. Stream processing offers low latency, real time reaction to events, and the ability to match real world process. Real time data streaming involves 5 layers: the source layer, stream ingestion layer, stream storage layer, stream processing layer, and the destination. Amazon Kinesis is a fully managed framework that provides high availability, durability, and scalability for streaming data. With Amazon Kinesis, you can focus on insights and analysis rather than worrying about streaming infrastructure. Thanks for joining me in this journey through the power of real-time data streaming. If you're looking to process and analyze vast amounts of data, Amazon Elastic MapReduce might be the solution for you. EMR is a managed service designed to handle short and long running workloads, providing high availability and cost efficiency. EMR is based on the Apache Hadoop framework, simplifying the infrastructure layer and reducing complexity. With EMR, you can launch a cluster in minutes, focusing on data processing rather than infrastructure management. Amazon EMR is ideal for various data analytics use cases, including log analysis, machine learning, and scientific simulation. It supports frameworks like Spark, Presto, and HBase, delivering petabyte scale processing power. With Amazon EMR, organizations can efficiently handle big data processing analytics, leveraging the power of AWS infrastructure and a range of supported frameworks. Discover the power of Amazon managed streaming for Apache Kafka with AWS. Amazon MSK allows you to run applications that utilize Apache Kafka, a platform for stream processing and a publisher subscriber based durable messaging system. Apache Kafka provides stream extreme fault tolerance, preserving the integrity and order of receiving data. It acts as a buffer between data producing entities and subscribers, delivering information on a first in, first out basis for an accurate timeline of produced data. Utilize the native Apache Kafka APIs to create data lakes, stream information to multiple sources, and power data analytics applications and pipelines, all within AWS. Amazon MSK is a fully managed service, eliminating the need to handle servers, upgrades, or Apache Zookeeper maintenance. So experience the freedom of build and create with the customizable community-driven tools and add-ons of Apache Kafka, all made accessible and hassle-free through Amazon MSK. Let's discover the core concepts of Kafka. Kafka revolves around three main ideas: producers, topics, and consumers. Producers create data, topics receive the data with extreme fault tolerance, and consumers read the data in order, ensuring it has never changed along the way. Kafka acts as a decoupling mechanism, easing tension among multiple producers and consumers. It consolidates log information from various resources into a single topic, serving as the single source of truth for microservices. Topics in Kafka have configurable retention periods and size-based retention policies, offering flexibility in managing data cost. Additionally, the number of partitions in a topic determines the level of parallelism. Kafka fundamentals concepts of producers, topics, and consumers, along with its role as a decoupling mechanism and its retention and partition features, makes it a powerful tool for managing data flow and processing. When creating your Amazon MSK cluster, there are two key elements to provision: broker instance and broker storage. Broker instances are work nodes that manage the Kafka cluster. They can be run within the same availability zones or across multiple availability zones for a highly available cluster. All data streaming into Amazon MSK is stored in broker storage housed with EBS volumes. These storage gains durability and fault tolerance and can be encrypted using Amazon EBS, server-side encryption, and AWS KMS. An important role about storage is that once assigned, the amount of storage can only be increased, not decreased. However, the broker storage can be auto-scaled upwards if the maximum capacity is reached. Are you a mobile app developer or a marketer looking to drive user engagement? Then you need to understand Amazon Pinpoint. Amazon Pinpoint is a powerful tool that allows you to run targeted campaigns to drive user engagement in mobile apps. It helps you understand user behavior, define which user to target, determine which message to send, schedule the best time to deliver the messages, and then track the results of your campaign. With Amazon Pinpoint, you can send the right data to the right customers at the right time, leading to more effective engagement and increased purchasing. It allows you to create targeted messages that are more likely to interest the users and less likely to cause them to unsubscribe to notification. Amazon Pinpoint provides graphical dashboards for real-time analytics, enables you to create target push notifications, and offers campaign scheduling flexibility. It also includes A/B testing and funnel analytics features, allowing you to analyze and improve the efficiency of your campaigns. So if you want to take your mobile apps to the next level, Amazon Pinpoint is the tool you need. Have you ever wondered how to extract valuable insights from text documents at scale? Let me introduce you to Amazon Comprehend, a powerful machine learning service by AWS that does just that. Amazon Comprehend is a machine learning service that uses natural language processing (NLP) to identify and extract valuable insights from text documents. It can analyze and detect meaningful insights from any text in UTF-8 format or in a semi-structured document such as Word doc or a PDF file. One of the key features of Amazon Comprehend is its ability to produce insights, which is just another way of saying meaningful data. It can extract key phrases, determine sentiment, and recognizes entities such as people, places, events, and more using a range of different APIs. Amazon Comprehend can detect key phrases in text documents and issue a score to determine a confidence level of the detected noun phrases. It can also determine the emotional context of a block of text, generating a percentage score rating for positive, negative, neutral, or mixed sentiment. Furthermore, Amazon Comprehend can recognize entities such as people, places, events, and specific dates and times, attributing a score to determine the confidence of its selection. In conclusion, Amazon Comprehend is a powerful tool for understanding and extracting valuable insights from text documents, enabling you to make data-driven decisions and enhance user. Let's discover the power of Amazon Forecast, a fully managed service that leverages machine learning to provide accurate forecast for time series datasets. Time series datasets are crucial for predicting future data points based on historical trends such as monthly sales, daily inventory, or hourly sensor readings. Accurate forecasting is essential for business success as under-forecasting leads to missed opportunities, while over-forecasting results in wasted resources. This is particularly critical for use cases like capacity planning, demand and inventory planning, and workforce planning, where errors can lead to unused infrastructure, excess inventory, or overtime cost. Amazon Forecast incorporates deep learning algorithms and statistical methods drawing from 20 years of forecasting at Amazon to deliver up to 50% improved accuracy compared to traditional models. It requires no prior machine learning experience, making it accessible to a wide range of users. The service allows for the import of three types of datasets: target time series, related time series, and item metadata. The time series dataset is essential for generating a forecast containing item IDs, timestamps, and associated values. More complex time series can include additional dimensions such as store locations in the case of a retail store. Amazon Forecast simplifies the process with a three-step sequence: data impact, predictive training, and forecast generation. This streamlined approach makes it easy to use, providing completion time estimates for ongoing datasets to import and predict training and forecast jobs. Have you ever wondered where Amazon's SageMaker fits into the machine learning ecosystem? So let's dive in and explore its role. At its core, SageMaker is a fully managed service that provides the tools to build, train, and deploy machine learning models. It's where you go when you need to build, train, and deploy models. SageMaker fits into the platform service range along with other popular services like Spark, EMR, Databricks, and Data Robot. It's the go-to platform for everyone from level 2 upwards. The Amazon learning workflow involves 4 key steps: preparing data, building the model, managing and training, and deploying it into a production environment. SageMaker plays a crucial role in simplifying and streamlining the machine learning process within the larger Amazon ecosystem. Ready to explore the world of machine learning with SageMaker? Let's get started. Let's dive into some architecture basis of multi-tier solutions. So first, let's talk about the LAMP stack. It stands for Linux, Apache, MySQL, and PHP. This stack is commonly used for building web services. Then there's the mean stack, which includes MongoDB, Express.js, AngularJS, and or Node.js. It's an evolving stack pattern that's important to understand. Next, we'll explore serverless architecture and microservices design. Serverless functions using Amazon API Gateway and AWS Lambda can be beneficial in multi-tiered designs. Microservices architecture patterns involves decoupling and independently deploy application components. Now let's clarify the concepts of multi-tier architecture. It involves separating services into tiers or levels such as presentation, logic, or data tiers. These tiers can be scaled and managed independently, providing a workframe for resilient and scalable application components. So lastly, we'll touch on highly available multi-tier architecture, which involves distributing application tiers across multiple availability zones. So this setup provides a highly resilient and scalable architecture, but it's important to note that it's quite complex. That's a wrap on your architecture basis overview. Ever wondered how to define the right tiering when designing in AWS? Let's break it down using a cake analogy. Imagine 2 cakes, a single layer birthday cake and a multi-layer wedding cake. The single layer cake represents a single tier architecture, while the multi-layer wedding cake represents a multi-tier architecture. In a multi-tier architecture, each layer is independent and can be sealed up or down to meet specific needs. This design suits cloud environments, allowing for truly scalable infrastructure. The most popular implementation of a multi-tier architecture is the 3-tier architecture, consisting of a presentation tier, a logic tier, and a data tier. Each tier can run on managed infrastructure in the AWS cloud. By separating out the layers, each can operate and scale independently, preventing overwhelming of one tier from impacting the others. This flexibility is key in AWS design. So next time you're designing in AWS, think of it as creating a multi-layered cake. In a single tier architecture, all the application services run on one machine or instances, sharing memory, process, and storage. This setup is suitable for simple services, small applications, or dev test environments that don't require frequent scaling. However, to scale a single tier of architecture, you need to vertically scale the instance or machine, which may not be efficient. While running a single tier architecture in AWS can enhance resiliency and scalability, it doesn't allow services to scale independently, posing a availability risk. If high availability and fault tolerance are required, a single tier application should be refactored into a multi-tier architecture. In a multi-tier design, the decoupled tiers can be independently scaled to meet demand, a significant advantage in cloud environments. For applications that don't need to be highly available and fault resistant, a single tier architecture may be considered. However, it's crucial to remember that the decoupled of tiers in a multi-tier architecture allows for efficient scaling to meet varying demands, a key benefit of building applications in the cloud. So let's dive into the world of multi-tier architecture for web services with AWS. Let's explore the design of multi-tier architecture for web services, architecture patterns using instances and load balancers, and how we could create a similar solution using serverless services and a full microservices design. For a multi-tier design, we need to implement the following AWS services. We'll be using the virtual private cloud to build our solution. There are four basic patterns of VPC, each serving different architecture needs. Now let's talk about subnets. A subnet can be either public or private, depending on its internet gateway and route. Public subnets have an internet gateway and a route to it, while private subnets do not. We'll also explore the role of security groups and network access control list ACLs in controlling inbound and outbound traffic at the instance and subnet levels. So designing a multi-tier architecture for web services with AWS involves careful consideration of VPC patterns, subnets, and security measures. So stay tuned for more insights into creating robust and scalable web services architecture. Now let's explore the different connectivity options available within an AWS VPC or a virtual private cloud. One way to provide internet access to instances is by assigning a public IP address or an elastic IP address. For instance, without public addresses, traffic can be routed through a NAT gateway, allowing them to access the internet via network address translation. Highly available NAT gateways offer advantage in deployment, availability, and maintenance compared to NAT instances. They are a managed service designed to handle burst activity and scale efficiency effectively. Another form of connectivity is using a VPN connection, which allows instances to route their internet traffic down the virtual private gateway to your own internet connection. So when designing a VPC, always ensure spare capacity for additional subnets and IP addresses to allow for scalability. Explore the various connectivity options in AWS VPC to optimize your cloud architecture. Now let's explore the differences between traditional EC2 instances and serverless service with a focus on AWS Lambda. Let's explore how to choose between EC2 and a serverless service on AWS. So let's start with EC2 instances. There are virtual servers running in AWS cloud, offering a wide variety of instance types optimized for compute, storage, or memory. However, they come with typical server maintenance tasks and associated cost. Whether it's a reserved instances or an on-demand rate, we'll be paying for the instances to be up and running, even if it's ideal for extended periods. Now let's dive into serverless computing. With serverless services like AWS Lambda, you're not responsible for any server. AWS handles the upkeep, maintenance, and security, making them inherently highly available. Billing for services like Lambda is based on actual usage down to the milliseconds level of execution time, offering cost efficiency and flexibility. In conclusion, understanding the trade-offs between EC2 and serverless architecture is crucial for making an informed decision. So stay tuned for more insights on this topic. So are you unsure whether to use EC2 instances or serverless servers for your workloads? So let's break it down. When your workloads is long running, memory intensive, or requires more processing power than Lambda can provide, EC2 instances are the way to go. If your workload has a lot of external dependencies or requires access to the underlying operating system, EC2 instances are also a better fit. And if you are migrating an existing workload from an on-premises environment, EC2 instances are essential for a lift and shift migration approach. On the other hand, if your workload doesn't require extreme processing, memory, or power, and you don't need access to an underlying server, a serverless implementation might be more suitable. Serverless architectures are ideal for unpredictable demand levels and maintaining multiple concurrent versions of your functions. So whether it's EC2 instances or serverless servers, understanding the right fit for your workload is crucial. Make the right choice for your business needs. Now let's dive into the cost comparison between EC2 and serverless architecture. So let's start with the workload deployed as a Lambda function executed 1 milli times per month. The cost just $8.54 per month. But if the demand massively scales up to 100 million requests, the cost skyrockets to over 854 per month. Now let's compare these two deploying the workload on an EC2 instance. With a single instance, the cost is close to Lambda at 9.67 per month. But for high availability, adding a second instance double the cost to just over £19 per month. In conclusion, there's no hard and fast rules when choosing between serverless and EC2. Serverless is ideal for rapid prototyping and event-driven applications, while EC2 is best for complete control over our infrastructure. Always consider your performance requirements and forecasted demand to make the best choice for your use case. So have you ever wondered about serverless architecture patterns? Let's dive in and explore the benefits of using AWS Lambda and Amazon API Gateway for a serverless design. In a serverless architecture, AWS Lambda and Amazon API Gateway provide managed computing and automatic scaling, making it easy to build highly available, scalable, and secure solutions. By using AWS Lambda, you eliminate the need to provision instances, manage operating systems, and worry about over or under provisioning. It also integrates directly with your AWS data tier, ensuring appropriate isolation and access to resources. The API gateway simplifies the deployment, monitoring, and security of APIs, reducing the amount of infrastructure management reduced. It also enables improved API performance via caching and content delivery. So whether it's integrating with the Lambda function or managing communication between code functions and services, the serverless architecture patterns using AWS Lambda and Amazon API Gateway offers a streamlined and efficient approach to building applications. So are you ready to explore the world of serverless architecture patterns? So let's get started. Now it's welcome to a comprehensive overview of various serverless categories and services available within AWS. Let's start by exploring the serverless compute services, which are crucial for any application. AWS Lambda, the pioneer in serverless services, offers event-driven functionality and has evolved significantly since its inception in 2014. When there's AWS Fargate, which allows you to run serverless containers for an unlimited amount of time, overcoming Lambda's execution time limitations. Moving on to serverless application integration services, we have Amazon Event Bridge, a serverless event bus, and AWS Step Functions, a serverless state machine service. These services play a vital role in connecting and managing data between various applications and AWS services. Finally, let's dive into serverless database services. Amazon S3, a scalable object-based storage system, and DynamoDB, a fully managed NoSQL databases, are just a few of the fantastic options available for serverless data storage. So with a wide array of serverless services and categories, AWS offers solutions for almost any application. I highly recommended exploring the coursework of any services that piqued your interest. So grab a coffee, sit back, and let's embark on this journey of AWS serverless exploration. Are you curious about the 7 R's and why they exist? Let's dive in and find out. The 7 R's exist to guide organizations in transitioning from an on-premises infrastructure to the public cloud, like AWS. Whether it's migrating a whole data center or hosting an existing application, the 7 R's help evaluate the most efficient migration strategy that aligns with business requirements. Migrating to the cloud involves addressing all components, not just the application itself. It includes considerations like customer data, communication, security, and ongoing management. So what are the 7 R's? They are rehosting, replatforming, repurchasing, refactoring, re-architecting, relocating, retiring, and retaining. These 7 R's provide a framework for focusing on the most appropriate migration method based on specific use case and needs. Are you considering migrating to AWS? Let's explore the different cloud migration strategies to help you make an informed decision. When migrating to the cloud, the lift and shift approach, also known as rehosting, involves moving your application to AWS without significant changes to the core infrastructure. This method is a quick way to move legacy applications to AWS, minimizing disruption and development cost. Replatforming, you can take advantage of managed AWS services, optimizing cost and producing automation and scalability. This approach allows you to move existing databases to a purpose-built environment, paving the way for great growth and innovation. Repurchasing involves acquiring new licenses from AWS Marketplace for applications like ERP or CRM, providing enhanced features and regular maintenance. Re-architecting, harnessing AWS benefits. Re-architecting allows you to fully harness the benefits of AWS by redefining how your solution operates, introducing microservices and event-driven architecture patterns. Relocating to VMware Cloud on AWS enables you to leverage existing VMware tools and skills with AWS infrastructure, integrating with native AWS services for greater innovation and scalability. Identifying valuable applications and shedding the dead weight within your architecture is crucial to streamline the migration process and optimize resources. Remember, a cloud migration doesn't require moving every application. Focus on areas that benefit your business and customers. So if you're considering migrating to AWS, let's explore the 3-stage perspective for a successful migration. The first stage, access, involves understanding your current environment and formulating migration goals. AWS Migration Hub and Migration Equalator are key services for this stage. In the mobilize stage, you will define your migration plan and identify any skill gaps. AWS Application Discovery Service and AWS Control Tower are essential for this phase. Finally, in the migrate and modernize stage, you will design your application solution for AWS. Depending on your migration strategy, you will utilize services like AWS Application Migration Service and AWS Database Migration Service. By following these 3-stage perspective, you can effectively plan your migration to AWS. Now let's dive into the world of cloud migration with the Migration Evaluator and AWS Migration Hub services. The Migration Evaluator, formerly known as TSO Logic, is your go-to for understanding your on-premises environment and projecting it onto AWS. It analyzes your compute, storage, and Microsoft licenses, providing cost-optimized solution for each workload. And leveraging its agentless collector tool, it can reduce cost by up to 50% when running in AWS. After collecting data for at least 2 weeks, the Migration Evaluator presents quick insights, showcasing assessment results, recommendations, and projected cost. It also provides a breakdown of cost modeling scenarios and full inventory of compute and storage resources. The AWS Migration Hub acts as the nerve center of your migration project, offering a dashboard view to plan, track, and manage your migration. It integrates with other AWS services to discover, audit, and manage the migration of services and servers to AWS Cloud Services. Now let's explore the AWS migration and modernization services that can help you manage the migration and modernize stage of your migration strategy. We'll cover the services that assist in migrating servers, databases, and applications, as well as how to migrate data from your data center to the AWS cloud. The AWS Application Migration Service is a recommended solution for a migrating application to AWS with minimal downtime and interruption. It works on a lift and shift approach, converting existing physical and virtual machines to run natively across AWS infrastructure. The database migration service is designed to migrate relational NoSQL databases and data warehouses from on-premises environments to AWS with minimal downtime and security in mind. It offers flexibility in migrating to and from different databases, making use of cost-effective DB solutions. The AWS Service Catalog is an organizational tool that simplifies the provisioning and creating of IT stacks, making resources creation easier while maintaining best practices and system security. With AWS Service Catalog, you have full control over what end users have access to, allowing you to apply constraints on the products within your portfolio based on predefined settings. This is just the beginning of your exploration of AWS migration and modernization service. Stay tuned for more insights. If you are looking for seamlessly way to transfer data between your on-premises data center and AWS storage services, look no further than AWS DataSync. AWS DataSync is a powerful service that simplifies the secure data transfer between different storage locations. It supports various storage services including Amazon S3, Amazon Elastic File System, Amazon FSx for Windows File Server, and AWS Snowcone. With its high-speed data transfer network protocol and end-to-end security measures, AWS DataSync ensures rapid and secure data transfer. It also supports encryption in transit at rest as well as data validation to maintain the integrity of your data. To begin using AWS DataSync, you will need to configure your destination storage, grant permissions using IAM roles, set up a transfer family server, and add a user to the server. Then you can seamlessly complete the transfer using a supported client. So experience the ease and security of data transfer with AWS DataSync. Start simplifying your data management with AWS DataSync today. AWS Know Family. Let's dive into what it is and what it consists of. The AWS Know Family is a range of physical hardware devices designed to facilitate data transfer into and out of AWS. These devices are essential for transferring data from the edge or beyond the cloud, such as your data center, and can also be used to transfer data out of AWS. For example, from Amazon S3 back to your data center. The Snow family consists of various devices including the Snowcone, Snowball, and Snowmobile, each offering different storage and compute capabilities. These devices enable you to run usable EC2 instances, process and analyze data closer to the source, and securely store files as objects using File Gateway for Amazon S3. With the AWS Snow family, you can efficiently transfer data at any scale, securely store files, and seamlessly integrate your on-premises storage with AWS. So embrace the power of AWS Snow family for your data transfer needs.